Hello, everybody, and welcome to my Chapter 8 presentation. My name is Taylor Richardson, and today we are going to go over some questions about algebraic reasoning, graphing, and connections with geometry. Do you ever feel like you are just drowning in problems and numbers and math and all things that have to do with math and solving problems? I do, but I promise that I'm here to help and I'm here to make these next few problems as easy as possible for you to get through. Today we're going to go over some things like the function machine with inputs and outputs, tangents on circles, slope formulas like finding the slope, and parabolas on graphs. So we'll start with question 1, and question 1 wants us to draw a graph for each of the scenarios that are given. And the first scenario is about filling up a gas tank for a truck that is going on a cross-country road trip. And so we can see in the graph in part A, I have the graph labeled gas on a road trip. And we can see where the red line begins, you can see it is sloping downwards until about the third little notch here. And then you can see that it stops and it just goes up in a straight line. That point on our graph is when the truck is filling up its gas tank. It's not going anywhere, it's not using any fuel, it's just standing still and filling up its gas tank. And then you can see once it fills up, once the line gets all the way to the top of the y-axis again, it starts going back down as it continues along the x-axis. You can see my labels on the x and y axis. The y-axis is labeled gallons. It represents the gallons in the tank, the gallons of gas the tank holds. And the x-axis represents the miles that the truck has driven. In part B, we are asked to draw a graph that represents an elevator going up and stopping on the floors in a building. We can see this represented by the green line. We can see it goes up and then it stops and goes across the x-axis, and that is when it is stopped on a floor and it's letting people in and letting people off. And then again, you can see it goes up to the next floor, and then it stops again, and this time it stops for a little bit longer. There might just be a couple more people needing to shuffle in and out of this small elevator. And then it continues to go up and stop at each floor on this graph. And you can see here again my labels. My y-axis is the floor numbers, and the x-axis is the time that is passing as it is going up and stopping on each floor. Part C of this question is asking about a ball that is being dropped off of a table. And when a ball is dropped off of a table, the very first bounce is obviously going to be the highest bounce because it is from the initial drop. So you can see here on my graph in part C, the height is at the highest point at the very first drop. And I don't know if you can see, but I do have a line right here on the y-axis that represents the ball actually initially being dropped from the table. And so it hits the ground at the point point 0, 0, where y and x meet. And then you can see how it bounces and comes up to 2, 1, 2, 3, 4, 5, 6 almost. And then it continues to go back down and bounce on the ground or the x-axis and so on and so forth. And then the final part of this question is about a flagpole's shadow throughout the day. And so obviously at the beginning of the day, when the sun is first beginning to rise, it's going to be casting on the flagpole and it's going to be casting the highest shadow. And as the sun rises throughout the day, when it gets to its highest point in the sky, it's going to be the flagpole will be casting the least amount of shadow. And so that is represented by this curved line on my graph right here. Question 2 is about functions, and just reading the question can seem really, really confusing because there's a lot of words and a lot of letters and it just looks like a bunch of jumbled mess. But I promise it's not that confusing. So the question gives us these two functions. F of x is equal to 3x and g of x is equal to x plus 8. So what this problem is wanting us to do is it gives us these four numbers, 0, 1, 2, and 3, but you can see they're kind of written in a weird way. The way that we say these when we see this is G of F of 0. Basically what that means is that we're going to plug 0 in for x in the f of x function, and then with that, so we would do 3 times 0, and so f of x would equal 0 because 3 times 0 is 0. We would plug 0 in for x in the g of x formula. So 0 plus 8 is 8. And that's represented here, right here, with this little function machine that I have for us. You put 0 in, and you are going to follow the rules of the functions, and you're going to multiply by 3 and add 8, and you get the number 8 as your output. Next, we have, for the rest of those numbers, we did 0 with that machine, and then we have 1, 2, and 3, and those are represented with these cute little robots. You can see their right hand, the input hand, is where the X goes. And then so for the first one on the left side of the screen, you can see we put a 1 in, and we're going to follow the rule by multiplying that by 3. So 1 times 3 is 3. And then we're going to add 8. So 1, when you multiply by 3 and you add 8, is equal to 11. And this rule follows exactly the same for the next two problems. We put 2 in, multiply by 3, and add 8, and you get 14. And as well, you put 3 in, multiply by 3, get 9, and then you add 8 and get 17. And you can see that represented right here in this handy dandy little table right here at the bottom for you too. Question 3 is about determining the slopes when you are given 2 points. So you can see here I have written the 2 points that you are given. You're given point P, which is 3, 1, and point Q, which is 5, 5. I have written above these points x1 and y1 for the first point and x2 and y2 for the second point. I have these written here because it is easier for me, personally, if I have them labeled, it's easier for me to plug them into the slope formula. And the slope formula is written up here in the top right-hand corner, y2 minus y1 over x2 minus x1. This is going to be the formula you use when you're given 2 points so that you can find the slope of a segment. So here we are going to plug in these numbers, y2 minus y1. So we're going to take 5 minus 1, and we know that equals 4. And then we're going to take 5 minus 3, and that equals 2. 4 over 2 is now our slope, and we can reduce that to simply 2. So we know that the slope is 2 given these points and putting them into the slope formula, and that is represented right here in this graph. So for part B of this question, we're going to follow the exact same rule. We are given point R, which is 5, 8, and point S, which is 5, negative 8. We're going to plug these into the slope formula, y2 minus y1 over x2 minus x1. We're going to do negative 8 minus 8 is equal to negative 16. And then 5 minus 5 equals 0. Negative 16 divided by 0, we know that we cannot divide any number by 0. It is not going to work. It just doesn't happen like that. So we know that when we see any kind of fraction or number like this, when we're talking about slope, that slope is going to be undefined. When that slope is undefined, when you hear that word, you know that the slope, there's not a slope. It's just a line that goes straight up and down. There's no slope. It's not moving to the left. It's not moving to the right. It's simply going straight up and down. So that's what's represented right here in part B. We have a slope that is undefined and is just going straight up and down. It is vertical. And so for part C, we are given the point U, which is negative 1, negative 4, and point V, which is negative 4, negative 13. We have those plotted right here on the graph, and we're just going to follow suit and plug them right into our formula, and we get negative 9 over negative 3, and that can be reduced to just 3. So even though we're given 2 negative points, we have a positive slope. Question 4 is about parabolas. We are given the 3 formulas or equations right here to the left, parts A, B, and C. Part A is y equals x squared. Well, there's no written y-intercept right there that we can see, and that is just because that is just our basic parabola, x squared. That is going to be the middle parabola or curve that we see, and it just goes right through the center of the graph, right through point 0, 0. And the next two, part B and part C, x squared plus 7 and x squared minus 7, you can kind of probably guess that the 7 is going to be the y-intercept. So x squared plus 7, x squared is going to be your curve, and then 7 is going to be your y-intercept. So this top parabola is y equals x squared plus 7, and then the bottom parabola is y equals x squared minus 7, and the minus 7 is the y-intercept, and the plus 7 is the y-intercept. Question number 5 is about perpendicular lines, and it can be kind of confusing at first. You might not recognize just exactly what you're supposed to do, but I promise it's super duper easy. In order to find the perpendicular line when you were just given an equation, all you have to do is find the slope of that line, and then you just can find a point on that line or the y-intercept, but all you have to do initially is find the slope. And finding the slope is a lot easier than you think. It's not going to require much work. You can really just find it by looking at the formula or the equation given. So we can see that our given equation is y equals negative 3/4 x plus 5. So this is in the form y equals mx plus b, m being your slope and b being your y-intercept. So m is your slope, so minus 3/4 is your slope of your given equation. In order to find the perpendicular slope, you are going to find the opposite reciprocal of your given slope. So your given slope is negative 3/4, and the opposite of that would be positive 3/4, and the reciprocal is you're flipping the numerator and the denominator. So the opposite reciprocal of negative 3/4 is positive 4/3, and that is written right here next to the perpendicular slope. Next, we're going to use the point slope formula that's written here, and that is y minus y1 equals m times x minus x1. And we're going to plug in the given point and our perpendicular slope to find the new equation for the perpendicular line is y equals 4/3 x minus 9. Our last question is about tangent lines. The question says, show and explain the equation of the line that is tangent to the circle of radius 9 at point 0, negative 9, and whose center is at the origin. So the center of this circle we can see is right here at the origin, or point 0, 0. The question is asking us to put a tangent line, or the line that is only going to touch the very outermost point of the circle. This is going to be, we know that the radius is 9, and that means that the farthest the circle is going to go out is 0.9 on the graph. So we can see our outermost point on the x-axis is 9, 0 and negative 9, 0. And likewise for the y-axis is 0, 9 and 0, negative 9. And so we have the equation for the tangent line written over here to the left. But we know that tangent lines just go right here on the outer edges of the circle, and so that's what each of these two red lines represent here. Thank you for watching my lesson on Chapter 8, and I hope you join me again next time.